Hello friends, in this video session we'll solve one problem on nodal analysis. Remember that in nodal analysis we find node voltages. So this method is also called as node voltage method. Here is the example. Find the current in 6 ohm resistor using nodal voltage. This is the circuit given. This question is asked for Mumbai University in December 17 for 10 marks. Here, this node voltage method is nothing but nodal analysis. Now, let us go for solution of it. As usual, in the nodal analysis, first we'll select a reference node. Let us take this point, which is a junction of 18 volt battery, 3 ampere current source and 6 ohm resistor, that is this point. Let us take this point as a reference. Mark it as O. So this is a reference. Now, what are the other nodes to be considered for nodal analysis? Here, this point, which is a junction of 18 volt battery and 1 ohm resistor. But between this point and reference, a battery of 18 volt is directly connected, so this voltage is 18 volt. Since voltage at this point is known, we will not consider it for KCL. Now this point. No battery is connected between this point and reference directly. Remember, this is a current source, not voltage source. So voltage at this point is not known, it is unknown. So let us mark this as point A. Now consider this point, which is a junction of this controlled voltage source and 6 ohm resistor. This point is nothing but this point. Now this positive sign on this voltage source indicates that voltage at this point is greater than this voltage by an amount of 2Vx. If voltage at point A is VA, then voltage at this point will be greater than VA by an amount of 2Vx. So this voltage is nothing but VA plus 2Vx. Since this voltage is expressed in terms of VA and this voltage also equal to VA, we will not consider it separately for applying KCL. So the only node where we can apply KCL is point A. To apply KCL at point A, let us mark current in different branches arbitrarily. Say that this current is equal to I1. This current is 3 ampere, known. Say that this current is equal to I2. Note that I2 is same as I. Our problem is to find current in 6 ohm resistor. So current in 6 ohm resistor is nothing but I, which is nothing but I2. So our problem is to find I2. Now apply KCL at point A. Incoming current at point A is I1, 3 ampere. So total incoming current is I1 plus 3. Only one branch is there where the current is outgoing, which is I2. So KCL at point A. Gives I1 plus 3 is equal to I2. Now let us express currents in terms of voltages. So we are writing now current I1 and I2 in terms of voltages. Before that, to mark this as equation 1. Now say, what is I1? I1 is nothing but current flowing in 1 ohm resistor. One terminal of this 1 ohm resistor is at 18 volt and the other is at VA. So the potential difference across 1 ohm is 18 minus VA, that divided by 1 resistance value, that gives me current I1. So current I1 is equal to 18 minus VA divided by 1, which is nothing but 18 minus VA. Now see current I2. I2 is the current flowing like this. It is the current flowing to 6 ohm resistor. So current flowing in 6 ohm can be obtained by potential difference across it. Now this terminal of 6 ohm is at VA plus 2Vx and this terminal is connected to ground. So potential difference across 6 ohm is VA plus 2Vx minus 0, that divided by 6, that gives me current I2. So I2 is equal to VA plus 2Vx minus reference 0 divided by 6. This is equal to VA by 6 plus 2 by 6 is 1/3. So this is 1/3 Vx. Say this is equation, all this is equation 2. Now substitute equation 2 in equation 1. So using 2 in equation 1, I1, which is 18 minus VA, plus 3 is equal to I2, which is VA by 6 plus 1/3 Vx. Let us combine the terms of VA. So this is VA. If I take it to this side, into bracket 1 plus, this is 1 by 6 plus 1/3 Vx is equal to, now this 18 plus 3, that is 21. If you simplify this, 6 into 1 plus 1, 7 by 6. So this is VA into 7 by 6 plus 1/3 Vx is equal to 21. Say this is equation 3. In this equation we find that this is one equation in terms of VA and Vx. So let us try to find Vx in terms of VA, so that we'll get one equation totally in terms of VA, by solving which I get the value of VA. Note that here this Vx is nothing but a controlling parameter. So let us see what is the value of this controlling parameter. Here this Vx is nothing but voltage across 1 ohm and current flowing to 1 ohm is nothing but I1. So when I1 flows from left to right, then we find that this terminal will be at positive potential, this will be at negative potential. But the drop across 1 ohm, which is Vx, given with exactly opposite polarity. This is positive here, negative here, but here is negative, here is positive. It means that Vx must be equal to minus I1 multiplied by 1. Let us put value of I1 from here. I1 is equal to 18 minus Va. This becomes Va. Minus and minus is plus, minus 18. Say this is equation 4. Now, using this value of Vx in equation 3, Vx is expressed here in terms of Va. When you substitute this value here, I will get one equation totally in terms of Va. So, using equation 4 in equation 3. We have Va into 7 by 6 plus 1/3 Vx is nothing but Va minus 18 is equal to 21. Let us combine the terms of Va. So this is Va into 7 by 6 plus 1/3. This 1 by 3 and this minus 18, it becomes minus 6. When I take it to this side, it will be plus 6. So it is 21 plus 6. Now if you simplify this, then we get Va into 9 by 6 is equal to 27. That gives Va equal to, this is 9, this is 27, so 3 will be here, 6 and that 3 will make it 18. So we have Va is equal to 18 volts. Our problem is not to find Va. Our problem is to find current flowing to 6 ohm resistor. And current in 6 ohm resistor is nothing but I2, which is Va by 6 plus 1/3 Vx. So from this Va, let us first find the value of Vx. So we are using this value of Va in equation 4. From 4, Vx is equal to Va minus 18, but Va is 18, so it is 18 minus 18, that is equal to 0. So we have value of Va, here Va equal to 18, Vx equal to 0. If I substitute the value of Va and Vx in equation 2, I get I2. Therefore, I2 is equal to 1 by 6. Va is equal to 18. This Va is equal to 18 plus 1 by 3. Vx is equal to 0. That is equal to 18 by 6, that is nothing but 3 ampere. Therefore, I2 is equal to 3 ampere. This is the answer. Thank you very much.